the trip to Singapore, and she's going to talk about the autonomous. Oh, this is the wrong title. Could we have the next slide, please? There we go. Use of maritime training simulators with humans in the loop for understanding and evaluating algorithms for autonomous vessels. So, take it away, Anete.
Hello, I hope you can hear me well. My name is Anete Vagale, and I'm a PhD candidate at Norwegian University of Science and Technology. And today I'll be presenting a conference paper on the topic of the use of maritime training simulators with humans in the loop for understanding and evaluating algorithms for autonomous vessels. Yes, so I think now we can clearly see the future with autonomy on waters. And this is probably the reason why we all are here. But this will definitely be a gradual transition in a way that there will be a long period of time when there will be autonomous vessels navigating on waters together with manned vessels. And I think a good example of that is recreational vessels that are sailed by people who enjoy sailing. And therefore, there'll be time when in these remote control centers, humans will have to be able to oversee interactions between both autonomous and manned vessels. And there are also some benefits of why these autonomous vessels should be introduced, and probably one of the most important ones is improved safety on waters, as some of previous speakers said that this autonomy on vessels will definitely improve safety several times. And another one is reduced costs of operation and also energy efficiency. That is an important part of the green shift. And if we want to introduce autonomous vessels, we also have to think of how to verify and test safety, performance, and robustness of these navigation algorithms in the guidance navigation control system. And as real-life scenarios and testing could be quite costly and impractical, and also it's very time-consuming and a bit dangerous, then we have to think of alternative approaches of how we can verify this safety of these algorithms and safety on the vessels in a bit different way. And in our opinion, it's also very interesting to do research and to see how humans will interact with autonomous vessels, because this is something that is new, and we still have to see how this interaction will happen in futures. So what we propose is that maritime training simulators that are used for training cadets with humans in the loop could be used as a test bed for understanding and evaluating these algorithms for autonomous vessels. So, what are these maritime training simulators? These are a vessel bridge replica with one or several large screens. And they also have all essential handles and equipment and also speakers that are needed for simulating the navigation of a vessel. These could also be labeled very serious games because they are made to be quite realistic, so that when cadets are practicing how to navigate the ship, they could practice in quite a realistic environment. And according to IMO, these simulators have been named as being realistic enough that some of the training hours in the simulator could be substituted by the navigation on an actual vessel, because it's possible to test more scenarios much faster. And here you can see a structure of how such simulator would look like. So in the middle, there's a simulator engine that generates scenarios and connects all the screens and handles. On the left side, there's the navigation bridge that the cadet is navigating. And on the right side, there's the main instructor screen, who is observing the navigation of the own vessel by the cadet. And currently, the main instructor is also able to put target vessels in this simulator that the cadet has to avoid. And this is done manually. Here is an example of a maritime training simulator by Kongsberg that is located in Norway. And here you can see on the left side the navigation bridge that has a large screen that where the surroundings are projected that are seen from the own vessel bridge. And then it also has a chair, handles for navigating the ship, and different instruments in front of the cadet. And on the right side, there's the instructor station with several screens where the instructor of the cadet can observe how the test is happening and see also information from radars, from the maps, and from the cameras as well. So in our paper, the goal is to propose a way how to evaluate the performance and capacities of these autonomous navigation algorithms by using these maritime training simulators with humans in the loop. And the reason for that is that we need to do a large testing of these algorithms before implementing them on an actual vessel on waters. And we are proposing two test setups that would be test setup A and B, where in the first one, the algorithm is the one controlling the target vessels while the cadet is navigating. And in the test setup B, the roles are reversed, so that the cadet is navigating the bridge and the algorithms control the bridge, and cadets or instructors can still be navigating the target vessels in the simulator. Yeah, here you can see the visualization of how we propose test setup A to B. At the bottom of the figure, you can see that operator is the one navigating the bridge, navigating all the controls and avoiding all the target vessels in the vicinity. And algorithms that control these target vessels could be both manually inputted by the instructor, or they could also be of autonomous algorithms. And in our opinion, this raises several important research questions, where some of them is how beneficial is it for navigators to know that the vessels they are trying to avoid are autonomous? And another question is it important for this cadet to understand how this autonomous vessel is thinking? And would this information be beneficial for the cadet, or would that be a distraction that would possibly lead to increased fatigueness and information overload? As for the test setup B, this is the one where the algorithm is the one controlling the bridge. And here you can see that roles are reversed. So the algorithm controls the bridge, while the target vessels in the vicinity are controlled by operators. And some important research questions from this test setup are, when we compare the navigation of the same scenario by a cadet and an autonomous algorithm, how their performance compares if we use the same metrics. So for example, in terms of safety or efficiency. And how does this navigation compare when there has been some more of the cognitive overload on the person? And would other autonomous vessels be able to perform better if they knew the intentions of other autonomous vessels? For example, if we have a test setup B, where some of the target ships are also autonomous. So these are some interesting research questions that we think have to be investigated, and that could be, for which we could find an answer when this would be implemented. Yeah, so in our opinion, this also uncovers possibilities for performing a Turing test for autonomous ships. This is something that is not done, and we are still not sure if we have to do that. But in our opinion, autonomous vessel has to navigate more human-like if we want to improve efficiency and safety on waters. And what we propose is that it would be interesting performing blind tests to detect autonomous and manual ships in the simulator. So let's say a cadet is navigating the vessel, and there are several traditional and autonomous vessels in the vicinity. And then after the exercise, the cadet is being interviewed, and he has to determine which ships were autonomous and which were traditional vessels navigated by officers, for example. And this could give us some indication of how human-like these autonomous vessels are performing. So to sum up, we have proposed that we could use maritime training simulators to investigate how well algorithms for autonomous vessels perform, and this could also open up possibilities of finding the ways how to improve these existing algorithms. And yeah, these simulators open up a lot of possibilities for more research setups than the two ones we have proposed so far, and this still can be explored. And of course, if we want to use the existing maritime training simulators for testing autonomous algorithms, there's a need for third-party interface to connect these computers and allow autonomous vessel to navigate the bridge or navigate or control these target vessels that are in the simulator. And finally, it is of great importance to investigate this human-machine interaction if we want to see future with autonomous vessels on the side with humans still navigating traditional vessels. Thank you for attention, and I'll be glad to answer your questions.
Okay, thank you. Let's just take a minute or two for questions. No online questions, so we have a question here.
Yes, this is Christian Kabus from Wärtsilä. Thank you for the great presentation. Just one question regarding the target vessels. You say the cadet would control them. Why not also use the autonomous algorithms to control the target vessels, which would lead to a more repeatable scenario? Why do you use the cadets to control them? Is it to introduce more uncertainty, or what's the reason for letting cadets control it?
Yeah, thanks for your question. How it is done so far is that when, let's say, when a cadet is performing exercise, the instructor is observing this exercise, and the instructor can set that now there will be a traditional vessel going from point A to point B in the cadet's path, and then the cadet has to avoid this vessel. So this is more of the traditional vessel approach that is used so far. And it's not always that the instructor or a cadet is manually steering that ship, but these are also some possible scenarios that could be tested to, because in these maritime training simulators, it's also possible connecting several navigation bridges to one instructor screen, to one simulator engine. And this is how it's done in the facilities in Norway, is that we have, I think, 5 or 6 navigation bridges that could be used simultaneously for navigation exercises. And then it's connected to this one simulator engine and one instructor's screens. Yeah.
Okay, any more questions? So is it part of, I could just have one question. Is it part of the plan? So a typical cadet training, you would carry out extreme scenarios like you lost the steerage or your engine is out, engine failure. Is it also part of the plan to test the autonomous navigation for these cases?
Yes, of course, because if we want to use these autonomous algorithms for real vessels on the sea, we have to test not only the traditional scenarios, but also, let's say, the unpredictable scenarios, the complex ones, because this is something we cannot test on waters because it's dangerous, it's very costly to do that. So I think it's of great importance to test these scenarios as well.
All right. Thank you very much.
Thank you.